So these notes can be found on my Venture webpage, and you can go to the Algebra 2 folder and make sure you print out not only the notes before you start doing this video, but also the properties and principles, because we'll be looking at those as well. And just bear in mind that I have to fit in 40 minutes of class time, what you normally would have about 200 minutes for. So these notes are very condensed and should not be a replacement for your textbook. You must read your text if you want to be successful in Algebra 2. Okay, so here's task 1. I will be going somewhat fast in the videos because I want to keep them to a reasonable size and because you have a pause button. So if you want to stop and do one of the exercises, especially the U-tries, but if you want to do one of the exercises on your own before you see my answer, hit pause and give it a try. Okay, this should all be review. It's quite basic, but they're very important definitions, and we need to make sure that you're very comfortable with them before we move forward. Ordering real numbers. I really want you to use a number line if you're having any trouble with subtracting integers or real numbers. Comparing numbers using less than or greater than. A number line can come in very handy for that. So if you want to compare -7 and -4, and like me, you get a little confused about opposites, negatives and positives, and you're having trouble remembering which one's greater, draw yourself a number line or look at a number line. I've made one available on in my school loop locker, so take a look. In this case, you can just look and see that -7 is less than -4 because it's to the left on the number line, and on the number line we increase as we go from left to right. So you try the next one. Again, when I say there's a you try, you should hit pause and give it a try, because I'm going to go right ahead forward. Now if I look at the number line, I see that 3 is here, -8 is way over here, so 3 is greater than -8. Again, this should be fairly basic. If it is not basic for you, make sure you're doing extra practice. The opposite of a real number, this is a definition. Two numbers are the same that are the same distance from 0, but on opposite sides of 0 are called opposites. An example is -7 and 7. What's the opposite of negative square root of 4, which is also known as -2? And that would be +2 or positive square root of 4. What is the opposite? This is a U try. What is the opposite of 8? Well, you hop to the other side of 0, and there it is at -8. Okay, now we're looking at absolute value. The absolute value is written like this. In case you haven't, I think you would have seen it in geometry, perhaps when you guys derived the distance formula. It's the distance between A and 0 on the number line. And I put in a little thought here to remember that distance is always positive. So absolute value is always a positive. It's like a machine where you put in anything and it spits out a positive number. So if you put in negative square root of 6 into your absolute value machine, it will spit out positive square root of 6. You put in 4, absolute value of 4 is 4. You try, absolute value of -5, that's a 5. So everything's a distance, so it must be positive. Adding real numbers. I'm including these instructions. A lot of us do these without really thinking about the steps that we're going through, but if you put the steps into words, these words do a pretty good job at describing what we do. When you're adding real numbers or integers, which is a subset of real numbers, if two real numbers have the same sign, like these two, then we're going to add their absolute values and then give the sum the same sign as the numbers. So the absolute values are 12 and 52 in this case. Their sum is 64, and we need to put this negative there because the original numbers were negative. So our sum is -64. A lot of people would just do that in their head. This comes in handy when you're getting into larger numbers. If you're dealing with very small numbers, you could even go back to your number line if you'd like. Okay, if they have different signs, like our first example, you subtract the smaller absolute value from the larger absolute value. So let's look at our two absolute values. We have 1.5 and 3.5. So we'll subtract the smaller from the larger to get 2.0. Now the sum will have the same sign as the larger. The larger was positive, so our answer is positive. Okay, now here's what I like because it's easy. Subtracting a real number means adding its opposite. So if I want to subtract 7 from 6, well, that's the same thing as adding the opposite of 7, which is -7. And then I can go back. I've made it into an addition problem. I can go back and use my rule. They have different signs, so I'm subtracting the smaller from the larger absolute value, which gives me 1. The negative is on the larger number, so my answer is negative. So I went a little bit fast on that one, but I'm just going back and using this rule. I took the absolute value of this, which is 6. The absolute value of this is 7. I subtracted the smaller, which is 6, from the larger, which is 7, which gave me 1. And then my answer had the same size as the larger absolute value, which is this one. All right. Now what about this one? 3 minus a -5. Well, we're adding the opposite when we subtract. So this is 3 plus a +5. Now one little trick that some of my students have told me, minus a negative, you can put those two lines together and make them into a plus. So that's just a little trick you can use. Okay, turn over the page. Now we're going to go over something you should be very familiar with, which is order of operations. Some of you know it as PEMDAS or GEMDAS. Please excuse my dear Aunt Sally. First though, because we're doing grouping symbols first, I want to talk about what a grouping symbol is. We know there are parentheses. We know there are square brackets. We know there are absolute value signs. But the one we sometimes forget is the fraction bar. Fraction bar. Because we want to evaluate what's in the numerator and evaluate what's in the denominator and then simplify if we're using the order of operations. Okay, so let's look at a couple of examples and apply our order of operations. Here you would use multiplication first because there's no grouping symbol and there's no exponent. Multiplication is next. That's 18 minus 6 plus 5. You know what? Let's go fill this in really quickly. Grouping symbols. E is for exponents. Multiplication and division come next, and when you do the multiplication or division, it doesn't matter what order as long as you go from left to right. These are at the same level. So multiplication and division, and then same with addition and subtraction. They're at the same level, but you go from left to right. So if you look at this, addition and subtraction, well, what we want to do is go from left to right. It doesn't matter which one, addition or subtraction, we do first as long as we go from left to right. So 18 minus 6 equals 2 plus 5 equals 7. Okay, when we go to this one, we want to do what's in the grouping symbol first. So that would give us 16 times 3 plus 5. And then, next, if you look at our PEMDAS, is multiplication. So 16 times 3 is 48 plus 5, that gives us 53. Now you try this last one. Remember, when you evaluate an expression that's within grouping symbols, you want to still apply the order of operations. So first we're going to do 18 minus 2 times 8. Well, that equals 18 minus, we evaluate what's inside the grouping symbol, and that's 18 minus 16, and that gives us 2. All right, so the distributive property. Once again, you should be familiar with this. I gave you a property sheet that summarizes all the properties in your first, I believe we're doing the first 5 sections of the chapter. The distributive property, here's the distributive property of multiplication with respect to addition, and here's the distributive property of multiplication with respect to subtraction. I'm not going over this in great detail because I'm assuming it's review. If you're having trouble, please come talk to me and ask questions. So it can be used to combine like terms. See how we have variables in these expressions that we're simplifying? And we call them variable expressions when they contain variables. I want you to practice these two because in both cases we're distributing a negative, and that's something some students sometimes forget to do properly. They especially forget to distribute it to that last term. So in this case we have 6x minus, we're distributing this minus 5 by multiplying it by x and by multiplying it by 3. So negative 5 times x is negative 5x, negative 5 times 3 is negative 15. Now I have like terms, so I need to combine them, and that gives me x minus 15. You try this one. And again, we're distributing a negative. You have 18y plus 4 minus 10y, and then it's negative 2 times